Good morning, Bearcats. We're going to continue today, 5.3, solving trig equations. We're going to be working with multi-angles and more solving. Our classwork today will be from page 396, problems 17 through 34, and that is all. And we're going to try to get through as many of these in our class period as we can. If we're short, or I may decide along the way to cancel out a few problems, so if I do, please pay attention so that you're working along with everyone else in your group. You will need your identity page, so please locate that and go ahead and get your spirals out and get ready to get started. Okay, we're going to start with problem 18. 18 is a multi-angle. We really haven't talked a lot about this yet. I want to give you the problem first. The problem is tan squared 3x equals 3. And we know this is a multi-angle because the angle itself, x represents our angle theta, so remember this is our theta, is 3 times theta. So we want theta 3 rotations. So that means that our graph technically would be condensed, and in the original 2 pi we would have 3 cycles of the graph. All right, so let's go ahead and start solving. If this is a square, then remember you can think, you're thinking over here, you can think, I guess we need our thinking face, you can think about this as the same as 3x squared equals 3. And to do that, you would get rid of the square by square rooting, and that's what we're going to do. So we're going to take this function, this is all one piece of information, and we're going to square root it. We're going to square root on the other side. This square root will get rid of our square, and we'll be left with tan 3x. Remember, on the right side, we were an artist, and if you were an artist, what do you have to do? That's right, you have to sign your artwork plus or minus. So we'll have plus or minus the square root of 3. Now that is what 3x is equivalent to. So let's solve for 3x first, and then we'll be able to solve for x. All right, so we're going to have 3x equals positive or negative square root of 3. So we're going to have plus or minus the square root of 3. Okay, let's think a little bit about where that is. If it's positive and negative, then that means that we could have tan positive. Well, tan is positive in the first and the third quadrant. We could have tan equaling a negative value, which would be in the second or the fourth quadrant. So we should have all 4 quadrants and 4 answers. The next thing you want to do is you want to look at your chart. The chart's on the board again. That is one thing that you will make sure that you know before the test, is that by now you should know it, is our chart. So you're going to look on your chart and you're going to find where tan is the square root of 3. Where tan is the square root of 3. So take a look. I'll give you just a minute to locate that. And hopefully you found that to be at pi over 3. So the reference angle in the first quadrant would be pi over 3. Remember, if this is pi over 3, our reference at the axis would be 3 pi over 3, and this one would be 6 pi over 3. So our 3x value is going to be equal to the theta rotation of pi over 3. This is 3 over 3, then this quadrant you would be at 2 pi over 3. If this is 3 over 3, this quadrant we would be at 4 pi over 3. And if it's this quadrant, this is 6 over 3, and if we're back to this quadrant, we will be at 5 pi over 3. All right, now we have solved theta for 3 times theta. We want to know what theta would really be by itself, so we want to solve for x. To do that, we would divide by 3 or multiply each of those values by 1/3. So I'm going to just put my 1/3 out here. I'm going to multiply each term by 1/3, and that will give me my actual x or theta values. So when I do that, I get pi over 3 times 1/3, which would be pi over 9. I get 2 pi over 3, which would be 2 pi over 9. I'm sorry, yes, 2 pi over 9. I get 4 pi over 3, which would be at 4 pi over 9. And finally, 5 pi over 3 times 1/3 would be 5 pi over 9. And this would be my values for theta. And I'd like for you just to list them all out like that. All right. Right now, I'm going to push pause. We'll come back to a couple more examples, but I'm going to push pause, and I want you to work examples, or problems 17, 19, and 20. So I'm going to push pause, and then we will, I'll come around and help you while you're working those based on this example, and then we'll come back and watch another example. I'll be right here. All right, let's look at problem number 21. Problem 21 is cosine cube x equals cosine x. Okay, in this case, first of all, we're in good shape because we have the same trig function, so we don't need to worry about that. But we probably do need to move them both to the left and set it equal to 0. So I will move cosine x to the left. So I'll end up with cosine cubed x minus cosine x equals 0. Then our next process will be to factor. Since they both have cosine in them, we will take out a cosine x, and we will end up with cosine squared x minus 1 equals 0. All right, make sure nobody has any questions about that step. If you do, we'll answer it right now. All right, now we have really two factors here. We have cosine and we have cosine squared x equals 1. Now we could make this simpler if we wanted to, or we can leave it. So we'll leave that right now. And we're going to set each of our factors equal to 0. So we will have cosine x equals 0, and we will have cosine squared x minus 1 equals 0. All right, cosine x equals 0. Well, if it's 0 or 1 or negative 1 or undefined, remember we're going to be at one of our big four corners. So I'm going to draw my little axis here. And I know that's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And cosine is our x value, and we want to know where that is 0. Well, cosine is 0 right here and right here. So the solution to this would be at pi over 2 and 3 pi over 2. Okay, so that's two of our solutions. Let's go on the other side. We're going to move the 1 to the other side, and we would have cosine squared x equals 1. We would square root, and we would get cosine x equals, ooh, looky here, positive or negative 1. Positive or negative 1. And we want cosine x where it is 1. Well, we have that same little picture. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And cosine is the x value, and cosine is positive 1 right here, and cosine is negative 1 right here. So that would be at 0 radians and at pi. So those are our two sets of solutions. So we have for theta, and you can say x then would equal pi over 2. You could say 0 first if you wanted. 0, pi over 2, pi, and 3 pi over 2. That put it in correct order. You can do that. That would be an extra Go Bearcat for you. But if you leave them boxed in your answer, that is fine as well. All right, I want you now to work problem 22 and 23. All right, go Bearcats. All right, we're going to work with problem number 24. We've got a couple of things going on here. One, we need to move everything to the left and set it equal to 0, so let's do that first. The other thing I notice is I'm a little perplexed and a little concerned because I have a sine and a cosine, and I'm going to need those to be the same trig function in a minute. But let's first get everything to one side. So I'm going to keep my 2 sine squared x. I'm going to subtract the 2, and I'm going to subtract the cosine x, and set it equal to 0. Now everything's on the left, and you could have done this before as well. I'm going to change my sine squared x. If I change cosine, it's going to be 1 over secant. That's not really helpful. So I'm going to change my sine squared x. Please look at your identity sheet right now at your Pythagorean identities. Look at your Pythagorean identities. Please realize that sine squared x is the same as 1 minus cosine squared x, and that would give us a cosine. So I have 2 times 1 minus cosine squared x. That's a really important step right there that you understand. I still have the minus 2, I still have the minus cosine x, and it's still equal to 0. Okay, so we have now the same trig function. We have this 2 outside, so we're going to have to distribute that 2. So we would have 2 minus 2 cosine squared x minus 2 minus cosine x equals 1. I'm sorry, equals 0. Okay, this is like we've been doing the last few days, but now we're combining this simplifying with solving. So you've just kind of combined two big things. So this is kind of a big problem and a very important problem to make sure you understand. This is quadratic because of the squared, so we need to put it in the right form. We need to put our squared term first. What I'm going to do is I'm going to go ahead and move it and then multiply everything by negative because I don't like a negative in the front, although I think it would probably be okay. It makes it difficult to factor. Or you could think of it as moving everything to the right and setting it equal to 0, whichever you like better. I'm just going to keep it, and I'm going to write negative 2 cosine squared x minus cosine x, and I have a positive 2 and a negative 2, so they actually cancel one another out, equals 0. So at this point, I could factor out a negative, or I could multiply through or divide through by negative. I'm going to divide everything by negative, which will change both of these to positive. So now I have 2 cosine squared x, and that's just an algebra. I wouldn't call it a trick, but just a manipulation, plus cosine x equals 0. Now I hope you recognize that they both contain a cosine, and we need to factor that out. So we would have cosine x, and then we would have 2 cosine x plus 1 equals 0. Now we have two factors, and now we can set equal to 0 to solve each factor. I'm going to move over to this side so you can see better. I'm going to set cosine x equal to 0. I'm going to set 2 cosine x plus 1 equal to 0. So cosine x equals 0. I think we've done this a few times today. That would be 1, 0. 0, 1, negative 1, 0, 0, negative 1. Cosine is our x value, where 0 would be here and here. So that would be pi over 2 and 3 pi over 2. So that's 2 of our solutions. All right, now let's go to this side. We would move the 1 to the right and divide by 2. Move the 1 to the right and then divide by 2. So when we do that, we would get cosine x equals negative 1 half. Negative 1 half. All right, so let's think through this. Cosine is negative. Well, all surfers to California. Cosine's positive in the first and the fourth, so it would be negative in the second and the third. The next thing we want to do is make sure you look at your chart and find your reference angle for when cosine is 1 half. Cosine is at 1 half at pi over 3. That's our reference angle. So on the x-axis, this is 3 pi over 3. So in the second quadrant, we'd be back 1. That would be 2 pi over 3. And from 3 over 3 forward 1 to the third quadrant, we would be at 4 pi over 3. And that would be our other two solutions. So there are our 4 solutions. That's kind of a big problem. All right. I'm going to give you a minute. I'm going to pause it. You can make sure you have it written down and understand each of the steps. You may ask me questions, and as soon as you do that, I want you to go on and complete 25 through 27. And then we've got one more example. If we run out of time today, we'll work on this example at the beginning of class tomorrow before our review. All right. 28 can be a little tricky. You will see this process more than once. You'll see this process repeated, but until you've seen it or actually worked problems like this several times, you may not think to do this at the beginning. If I can change, since neither one of these, well, actually tan is, but neither one is a sine or a cosine, if I could get to sine or cosine, sometimes that's very helpful. Let's just use our reciprocal identities and see what happens if we make some changes. If I put secant, I could make secant over 1 over cosine x. And then I could make tangent sine x over cosine x. It's still equal to 1. All right, I have a really nice situation here. Because they're both the same denominator, I can combine them pretty easily. So I could write this as 1 plus sine x all over cosine x equals 1 over 1. Now I have one fraction equal to one fraction. When I have a fraction equal to a fraction, you're able to cross multiply and solve, and usually I think that's the best way. And with the ones, it's going to be really easy for us. So if I do 1 times 1 plus sine x, I get 1 plus sine x. If I do 1 times cosine x, I get cosine x. And then I'm in a bit of a conundrum. I'm in a little bit stumped here. I don't know really what to do yet. I really don't know that changing sine to cosecant is going to help me. If I change sine back to sine over, 1 over cosecant, that's really not going to be very helpful. So here's what I'm going to do. If this was 1 plus sine squared, would that give me something? 1 plus sine squared. Not sure that would help me because it would be 1 minus sine squared. But if this was a cosine squared, couldn't I change that to a sine squared term? I think I could. So to get cosine squared, I'm going to have to square both sides. Do want to make a big note. If you introduce a square into your problem, wasn't there to begin with, then you have to check for extraneous solutions. And it's only if you actually decide to square something. So we're going to try that to see how this works out. This is a kind of a hard problem. All right, this does some really, really good practice in our algebra skills. If we have a binomial and we square it, remember, that is like 1 plus sine x times 1 plus sine x. That's going to end up being a trinomial. The shortcut to squaring a binomial is taking the first term and square it, so 1 squared would be 1. Multiplying everything together, 2 times 1 times sine x would be positive 2 sine x. And then sine x squared would be positive sine squared x equals cosine squared x. All right, again, we really prefer to have all one trig term. So if I change my cosine squared x to sine, 1 minus sine squared x, I would have all sines. We're going to do that and see where that leads us. Remember, this is a bit of a puzzle, and occasionally, like I mentioned the first day, you might find yourself like you're on the way somewhere and you find yourself in a cul-de-sac and you have to turn around and start over. So hopefully we won't find too many cul-de-sacs, but you should find a few when you're practicing, just because that's the nature of this work. And then you'll get out of the cul-de-sac and you'll know what to do better the next time. All right, so 2 sine x plus sine squared x. And I'm going to change this to equals cosine squared x is 1 minus sine squared x. I'm going to move everything to the left and set it equal to 0. So if I move the 1 over, it's going to be minus 1. That's just going to cancel. If I move the negative sine squared x over, it's going to be positive sine squared x. So plus sine squared x. All right, so at this side, I'm going to put that first since that's my higher degree. I have 2 of those. So I have 2 sine squared x plus 2 sine x equals 0. I'm finally getting somewhere. I'm going to come over here and try to finish my problem. All right, so I'll start with my 2 sine squared x plus 2 sine x equals 0. All right, now I'm at a point where I have to factor something. I'm going to factor out a 2. They both have that, and they both have a sine x. So 2 sine x, parentheses, I need another sine x, plus I have that, which is 1, equals 0. All right, there are 2 factors you can set equal to 0. So you have 2 sine x equals 0, and we have sine x plus 1 equals 0. There's kind of our 2 parts. On the sine x equals 0, I would divide by 2. That's still 0, so I have sine x equals 0. Let's think about that. I know I have 1, 0, 0, 1, negative 1, 0, 0, negative 1. Sine is the y value, so it would be 0 here and here. That would be at 0 and at pi. So that would be 2 of my possible solutions. I'm saying the word possible because we need to check to make sure neither one are extraneous. So we have to be careful about that in a minute. We'll check those out. The next one, I'm going to move the 1 over, and I get sine x equals negative 1. Well, sine is negative 1 right down here, and that would be at 3 pi over 2, which again we're going to have to check out for extraneous solutions. All right, so let's talk about this. Let's go back and plug in 0. If I have secant 0, at 0, secant is the reciprocal of cosine. Cosine, let's draw our little thing here at 0, 1, 0. Cosine is 1. The reciprocal 1 is 1. So for this, that would be a 1 plus. For tan at 0, 0 divided by 1 is 0. So tan is 0, so that would be plus 0, and that would in fact equal 1. So I think that checks out. Let's try pi. Okay, at pi, our ordered pair is -1, 0, and 0. So secant is the reciprocal of cosine, so the reciprocal of -1 would be a -1. 0 for tan at pi would be 0, so that would be plus 0, which would be a -1. That doesn't work. So that makes pi not a solution. All right, let's try 3 pi over 2. At 3 pi over 2, that's down here at the bottom, we have 0 and -1. So secant's the reciprocal of 0, which would be an undefined term. You can stop right there if you get an undefined term. Can't happen. Cross that out. So our only solution this time is 0 radians. All that work just to find 0. Know you're excited about that. All right, so the last few problems I want you to try to work will be problems 29 through 34. Work as many of these you can, and then we'll pick up there tomorrow, and I hope you have a great day. So keep on working. Go Bearcats.